transformational leader, sorry,
Hello?
lots of things popping up on the screen. I can hear you. Apologies.
Okay.
Transformational leader that leads from the heart while balancing experience and education to drive results. Currently, he holds a BTech in petroleum engineering with Rivers State University, an MEng with University of Port Harcourt, and a PhD student with Emerald Engineer Institute, EEI, with research interest in petroleum economics, management, and policy. Christian is a researcher and have successfully published and co-authored different technical papers. Christian loves coaching and mentoring young engineers so that they can succeed in their career. He enjoys playing football, chess, and traveling. He's married to Beatrice Calabo, and they are both blessed with 2 kids. Ladies and gentlemen, with your virtual applause, and if your hands are not busy, could you make welcome the moderator of this monthly technical meeting, Engineer Christian Calabo. Thank you very much, sir, and welcome. Engineer, you can come off mute now, please, if you can hear me.
Wow, thank you very much, Dr. Jude, for that wonderful introduction. Good evening, everybody. I want to use this opportunity to make welcome each and every one of us for this great section. Like you've all been informed, my name is Christian. I'm a production engineer with NE Nigeria with over 10 years of experience. Today, I will be moderating this program for the technical paper section. But for a few notes before we start this technical presentations as follows. We encourage all participants, for this meeting to do mute their mics while the speaker is presenting his paper. This is so that we don't interrupt his flow of thoughts with background noises. Secondly, at the end of his presentation, we will entertain your questions. Kindly raise your hand, using the raise hand button. Alternatively, if you're comfortable typing your questions, please please feel free to use the chat box. And lastly, it is our expectation that today's Q&A, that's the question and answer section, should be very interactive, because what the speaker is bringing to the table today it borders more on our core operation here in the Niger Delta environment, region and beyond. So we urge all the participants to take advantage of this presentation and ask critical questions that it affects their pipeline operations. So without wasting much of your time, I want to bring in the speaker for today. He will be the major anchor person. He will be presenting the technical papers. He is a pipeline specialist with over 15 years of experience. He's also a PhD. Currently, he's a PhD holder in mechanical engineering with core interests in industrial metallurgy and corrosion management. He holds a master's degree in mechanical engineering with interest in engineering material design and a bachelor's degree in mechanical and production engineering. He's a UK chartered accountant, a current certified engineer, and a chartered energy engineer of the Energy Institute London. He is a member of American Society of Mechanical Engineers, Nigerian Society of Engineers, as well as London Institute, Energy Institute of London, and a member of the American Petroleum Institute as well. He is an alumnus of Harvard Business School, Executive Leadership Program with first-hand knowledge to lead team and deliver results. He has authored and he has also co-authored several publications in journals like World Pipeline Magazine, Industrial Engineering Letters, Nigerian Research Journals of Engineering, Environmental Sciences, among others. Please, let's do well, put our hands together and let's make welcome Engineer Dr. Henry Osabohon. Please, you can do well. If you're not busy, please do well, clap your hands as we make welcome for him to deliver his paper. Thank you. Engineer Henry, you can come on, kindly mute yourself and the floor is yours.
Yeah, good evening, everyone. I believe you can hear me.
Loud and clear.
Yeah, thank you for this great opportunity to share my knowledge with you. And I am confident after the section, at least everyone will have something we've learned, something we can take home. So I will just quickly, 1 second. Just 1 second, I'm trying to share my screen. Can you see my screen yet?
Yeah, it's up, but it's not on full screen yet.
Full screen, I'm trying to, okay, one.
Yeah.
We can see, right? Yeah. So
Yeah.
today I'll be talking about alternating current corrosion of underground hydrocarbon pipelines. I've been introduced. My name is Engineer Henry Onyemosabo. Here I hold a PhD in mechanical engineering, and my core interest is in industrial metallurgy and corrosion management. So the discussion will be centered on corrosion of pipelines, and as the oil and gas industry, as we all know, is a lifeline of the Nigerian economy, providing over 80% of the country's revenue. The industry relies majorly on pipelines to move its product from the source to the terminal. And over 137 pipeline failures have been were reported in the Niger Delta area between 1999 and 2005, with corrosion accounting for the most costs of these failures. Several failures have been reported a number of these failures we know. I'll talk about Bodo. Bodo is in Ogoni. This happened around 2008. The community believes that this pipeline may have failed due to poor maintenance, due to corrosion, but the operator feels otherwise, that this may have happened due to sabotage. But whatever, this pipeline failed for a reason. Agoda Brass oil spill, everyone knows, confirmed that this pipeline failed due to corrosion. There are several other cases that have happened in the course of history. And when this happens, it causes lots of damage. Our environment is impacted on, the livelihood of people also impacted on. So it's really very unfortunate to see these things happen. It becomes of interest that we have to find a way to make sure that these things don't happen. Our pipelines don't need to fail, either for any reason, particularly due to corrosion. So we'll talk about corrosion cycle. Just like, I believe you can hear me clearly, please. Hello.
Yes,
Yeah.
Henry, you're clear. You can go ahead.
Okay. Corrosion, just like the human life, a man is born on a particular day. He goes through life, through a lot of work. I will not say hard work. Challenge, you need to put in so much to get things done. And at the end of the day, it's a natural tendency that the man returns to where the man dies, he returns to where he came from. So also corrosion. So also it applies to corrosion. Corrosion is a natural process. When these metals, when they exist in their natural state as ores, as combinations, as oxides. And in that state, they are not useful. It's just like a man not being born. When a man is born, he has to grow up to the point that he becomes useful to the society. Now, to make this metal useful for everyone, to make it metallic and useful, you can apply it in your industries, you can apply it in your homes. You need to introduce a lot of energy to these compounds, to these ores. And when you introduce this energy, you bring it to the state that it becomes useful. Because of this energy you've added, it's like a state of unrest. The metal on its own will want to return to rest. Returning to rest is like someone dying or kind of going back to where he came from. So there's a natural tendency for these metals to return to their source. So our duty as people, our duty as engineers, people who use these metals, is to prevent, is to stop this process from happening, is to kind of mitigate, control, trying to put a control over this natural process of the metal returning to the source. We can see the cycle from the ore state to the point where it becomes a metal, and the corrosion trying to take it back to the ore state. There are different forms of this corrosion. They are listed here, not only 10, there are more than 10, but we're going to talk about straight current, the number 7 of it, straight current corrosion. As the name applies, stray, meaning that it's not intended for the pipeline, like stray. It's meant for some other purpose, but somehow it's coming to your pipeline. Your pipeline is transporting your crude let's say from your wellheads to the terminals. You don't want anything to happen to these pipelines, because if they happen, you're going to lose your containment. There will be loss of containment, and the environment will be impacted on, and that's going to be unfortunate for everyone. So you have currents, for whatever reason, currents going on their own for some other purpose, and they find their way to your pipeline. They destroy your pipeline. So we have basically 2 forms of this straight current. You have direct current, straight current corrosion. That's the type of corrosion that is caused by direct current supply on your pipeline. And you have alternating current corrosion. This is also a form of corrosion that is caused by alternating current supply on your pipeline. So direct current is a subject of its own, has its own sources. But today we're going to talk about alternating current. As the name implies, alternating, that means the current is going on the positive wave direction and also going on the negative wave direction. For direct current, it is steady. I know a number of us, it's like basic knowledge. We know, basically we know the difference between alternating and direct current. So alternating current is just fluctuating, going positive, comes to 0, goes to negative, goes back to 0, then again positive. So alternating corrosion, simply we have the high voltage transmission line. Now, we have different sources of this alternating current, like interference. Interference means in trying to interfere with your pipeline. You have this high voltage transmission line, which is one. You can also have electrified railways, like advanced countries where they have electrified railways. You could see your railways introducing alternating current to your underground infrastructure, metallic infrastructure. So this case, we are not very, very common with these electrified railways. So we're going to center this discussion on high voltage transmission lines, which we have very much around us. And the Niger Delta area is one of such areas that we have this high voltage transmission line. For this corrosion to happen, there should be a high voltage transmission lines. And you also have pipelines laid in common corridors with these high voltage transmission lines. It's like a common practice because we want to reduce impact on wildlife. We want to make it easy for inspection, in the sense that if I have inspectors going through the right of way, checking on the high voltage transmission line, they could also take a look at my pipelines. So it makes like easy inspection, easy maintenance, everything, just pack everything on one corridor. And when you have this case, you do it for convenience. You have a positive approach. I'm talking about the pipeline operators and the power operators. They just want to reduce also cost of compensation, because if I put my pipeline on this right of way, again, I take some other infrastructure to other right of ways, I have so much of compensation to do. So with this positive mindset, I want to bring everything together without considering that this infrastructure, they communicate amongst themselves, and they could impact negatively also on themselves. So alternating current corrosion is just a type of corrosion initiated by the movement of AC current out of pipeline. So this high voltage transmission lines, through induction, introduce this AC voltage on the pipeline. The point where this current enters the pipeline, it even offers more protection to the pipeline. It kind of even keeps it safer at the point where it is introduced. The problem is the current needs to leave the pipeline to complete the circuit. I know maybe there's if electrical engineers are here, they will understand that the circuit needs to be completed. So the current enters the pipeline. It also needs to leave the pipeline. So at the point where it's leaving the pipeline, it causes the corrosion, like what we can see on figure 6. So you can see an indication like this, or figure 6, at the point where it's leaving the pipeline, like a pitting. So these pictures, when you see them, you can imagine that this may be due to alternating current effect. Now, in 1992, Shell, they constructed a pipeline, about 412 kilometer pipeline, 10 inches in diameter, a high pressure ethylene pipeline from Grangemouth to Stanlow. Then in 1994, Shell conducted like an you call it like ILI, inline inspection, intelligent pig. You introduce an intelligent pig that goes through the line, checking for possible defects, possible loss of metal walls in the pipeline, to know if the areas where you have corrosion going on. So when this inspection was done, they realized that there were some points where they had this pitting, these indications. But in their mind, they probably felt that this may have been due to maybe microbial action, or maybe other forms of corrosion. So they did their part as corrosion and inspection require, that they reinforced the section, they did all they can, they sleeved that section to improve and increase the wall thickness and all that. Then in 1999, they repeated the same inspection. They discovered that this same pitting was also introduced, same area and same indication. So they had to, this probably must have been as a result of something else. The cause they believe likely still there. So they started investigating, and they introduced forms like corrosion coupon, and they monitored the coupon. They checked the alternating current. They checked the facilities they had around. They had a high voltage transmission line of very high capacity laid along this pipeline. And from the test station, they used like a coupon to monitor if this high voltage transmission line was interacting with the pipeline. And they discovered that the alternating current density in this section was way more than the allowable limit. And to this extent, it could corrode the pipeline. So it could cause this form of corrosion. So these are all that they put all together, and they were able to confirm that this high voltage transmission line was indeed interacting with the pipeline and impacting on it to the point that they could lose containment if they leave the situation as it is. Not only for this Shell pipeline, some other pipelines owned by this City of Kitchener, the Trans-Northern Pipeline. So the thing is, the pipeline laid in the same corridor, meaning traveling along the more you have this pipeline traveling along the same routes with the high voltage transmission line, the more susceptible the pipeline. The farther away the pipe, the closer the pipeline also to the high voltage transmission line or the source of alternating current, also the more the impact. So these are factors to consider. So for these cases, you can see the pipeline traveling over 4.4 kilometers on the same route with the high voltage transmission line. You can imagine that the exposure is massive. Then you can see the distance of the pipeline also, of the pipeline from the high voltage transmission line. So these are factors. So there's a problem in in Nigeria, narrowing it down to the country, because we've given instances of things that cases that have happened outside Nigeria. For our own Nigeria, we have our law restricting public utilities to common corridors for the common good, because they want to reduce cost of compensation. They want to make it easy to manage, for surveillance. They don't to limit impact on wildlife. So so we are predisposed. We can have this case of alternating current corrosion because pipelines possibly are by law, just for the positive reason, they are in common corridor with high voltage transmission lines. And in Nigeria, or not even only in Nigeria, the main primarily to protect pipeline, the first and basic thing to do is to coat this pipeline. But as the process entails, no matter how you do your coating, there must be discontinuities. In the technical side, we call it holidays. The coating going on holiday, that means there is a defect, the discontinuity in the coating. So discontinuities must exist no matter how tiny. So that's why we introduce cathodic protection. Cathodic protection is like trying to protect that pipeline for those small holes that the coating have missed, those defects that we find in the coating. The cathodic protection is meant to protect the pipeline at those points. But unfortunately, AC corrosion is unique. For other forms of corrosion that I've told you, the lesser the coating defect, the lesser the chances of corrosion happening. Like if my coating is good and I have an effective cathodic protection, those forms of corrosion may likely never happen. But alternating corrosion is unique because it's the reverse of other forms of corrosion. The smaller the coating defect, the more the tendency of alternating current corrosion happening. So it's either there is no defect at all, or even the alternating current will prefer a larger defect, like it will prefer a bigger opening of the coating on the pipeline than even smaller, meaning that the smaller the coating defect, the more the tendency of alternating current to corrosion to happen. So we're going to center the discussion a little bit on, because we have different types of communication between this high voltage transmission line and the pipeline. We have inductive, we have capacitive, we have resistive. These are other forms, but we're just going to look quickly on inductive. We're going to look at the resistivity of the soil and the coating defect side. These are factors that influence and affect that make this corrosion to happen. What's like the significance of this discussion? It will help pipeline operators, power line operators in choosing their right of way, their ROWs. Now we can know that this pipeline actually communicates, this high voltage transmission line communicates negatively with this pipeline. So we need to keep them apart. We need to separate them. We need to maintain standard distance of separation. We will not, with intention because we want to reduce cost, then we just pack everything together. This is wrong. We need to measure to what point they are interacting amongst themselves. And if we do that, if we don't have failures, we will maintain our oil production, because if these lines fail, you're definitely going to shut down those lines. You're going to stop production. This will affect the economy of the country at large. And if you lose your containment to the environment, you polluting the environment, you also increasing your security, you're jeopardizing security, because people will lose their source of livelihood and they will resort to crime. So to a very large extent, this topic is very significant, and it also brings the awareness to you that if you have a pipeline laid close to a transmission, a high voltage transmission line, you have to stay clear. That's why you see some safety signage, don't go close, this and that, because these high voltage transmission lines introduce currents to these lines that if you touch them, because the standard, the API standard recommends that the induced AC voltage should not go beyond 15 volts for human safety. So, but this can happen due to faults and other reasons that the voltage on the pipeline may exceed 15 volts, meaning that if you touch it, you could be electrocuted. So there is this maybe you're ignorant of the fact that this line could be charged and you touch the above ground pipelines, and unfortunately you could be electrocuted. So several studies have been done on corrosion, but the bulk of these studies have not been narrowed to this AC corrosion and the contributing factors. So basically, what is the theory? The same concept of corrosion that happens. For corrosion to occur, a number of factors must exist. There must be an anode, there must be a cathode, and you must have the electrolyte, and there must be a point of connection between the anode and the cathode. The anode is the positively charged electrode. The cathode is the negatively charged electrode. The electrolyte is like the environment, like the soil. I'll just bring it to reality, the pipeline that we are talking about. Now, in the pipeline, you will have a section of the pipeline, maybe due to manufacturing difference, for whatever reason, you have a section of the pipeline being more positive and the other side being less positive, that's being like the cathode. Now, if you have two metals coming also together, either because they're of different grades, because you may have X60 pipe, you may have X52, you bring them together, you find out that one of the pipes could become like the anode, one of the sections, like, for example, we are doing sectional replacement or partial replacement of the pipeline, and we are not using the same grade and the same composition of pipe, we bring in different pipe, different material. Then you find out that one section will be like the anode, the other section will be like the cathode. The part that is the anode, we corrode on behalf of the part that is the cathode. So what am I trying to say? The metal that is that is higher in the electrochemical series, we tend to corrode on behalf of the one that is lower in the electrochemical series. Now, in the electrochemical series, we have metals like magnesium, we have metals like zinc being higher than iron, meaning that if I bring zinc or let's use magnesium, because most often in practice, we use magnesium as a sacrificial anode for the metal, for iron, like in pipeline. So if I bring magnesium in contact with iron, the iron will remain protected for life. Rather, the magnesium will be giving out its life on behalf of the iron. So in this case, the magnesium is the anode and the iron is the cathode. So this can also happen to iron. If you bring iron in contact with another metal that is lower, the iron will begin to corrode. That's why we need to watch. I'm just giving just a general overview of what corrosion, how it happens. Now, if in a pipeline, we have like the anode, what happens is the metal goes into solution. The metal, like you have the iron, it will release I'm talking about when if the corrosion is to progress, it will release positive ions, ion ions into the electrolyte. The electrolyte, now we have the soil containing water and oxygen. So when it releases positive ion into the electrolyte, then protons goes into the electrolyte, leaving electrons uncatered for. Electrons, like, they become stranded. They don't know where to go. So they follow through the metallic part connecting the anode and the cathode. They go to the cathode region to enable reduction to happen. Now, in the anode region, oxidation is happening, and in the cathode region, reduction is happening. So when they oxidize, they will also produce hydroxyl ions that we combine with the ions, the ion ion, and form iron hydroxide. No, this iron hydroxide dehydrate to form rust. So basically, for corrosion to happen, there must be an anode, a cathode, and an electrolyte. So for us to make this not to happen, if we displace the anode, there will never be corrosion. If we displace the cathode, there will never be corrosion. If we are also able to extract water and oxygen from the electrolyte, there will also not be corrosion. So this just a simple understanding. So cathodic protection is like we are trying to what? Protect the pipeline also. We're trying to help the natural process. These pipelines are at risk. So for my pipeline to be protected, I want to force it to remain cathodic, because as long as my pipeline remains on the negatively charged electrode, it will never corrode. So the basic protection measure is to ensure that our pipeline remains cathodic. So if our pipelines remain cathodic, they will remain protected. So AC corrosion is one of those examples where the anode is there, the cathode is there, and the electrolyte, in the sense that the ion itself is going into solution, dissolving, and combining with the hydroxide to form ion hydroxide. What happens, like I told you when at the beginning, that alternating current, you have a situation of current going to the positive wave. Again, it comes to zero, then negative wave. At the same time, it goes, just it continues like that as it happens. So what happens is when it goes to the positive wave, it forms passive film. Passive film means it just forms some deposits. When the current goes down now to the negative wave, this deposit dissolves. It dissolves means it forms rust. Again, when it goes back to the positive wave, the parent metal further forms passive waves. It returns to the negative wave, that same passive wave dissolves again. So as long as this process continues, you have a situation where it goes to the positive, passive wave is formed, it goes to the negative, it dissolves. So this metal will continue to lose itself till it's of no existence. Can you hear me, please? Am I being
Yes,
heard?
go ahead, please, Engineer Henry. You're loud, please.
Okay, so this is what happens for alternating current corrosion. The wave you have going to the positive, then to the negative, it goes to the passive films, and again it dissolves. So these are just, so for this corrosion not to happen, you have these cases where if you go positive and you go negative, is less than 3, it will not happen. If the negative side is less than 1, if it's insignificant. So as I said, for corrosion to happen, all of these situations must be there. If you're able to eliminate any of them, it will not happen. So it's just like trying to prevent alternating corrosion. If I'm able to prevent the negative wave, meaning that that metal will never dissolve, rust will never be formed. So this just according to ISO, that if the negative wave, which is the DC density, is less than 1, the passive film cannot dissolve. If the AC density over the positive and over the negative is also less than 3, the process will also not proceed. It will just on its own become insignificant. Now, if the AC density also is less than 30 A over M square, then you also find the process will find it difficult to happen. So for AC corrosion to happen, the main center of interest is AC density. AC density is the problem. If the density of alternating current is high, corrosion will progress on that point. If it's low, you have it also controlled. So for AC density to happen, the high voltage transmission line must introduce current. There must be AC voltage inside the line. AC must be introduced. And secondly, for this to happen, you have to consider the resistivity of the soil. If the resistivity of the soil is high, the current can't come out from the pipeline. It will resist this flow. Also, you find out that AC corrosion will be controlled. If the diameter also is so big, that means the AC density will be low. So what I'm trying to say is that AC density is directly proportional to AC voltage, meaning that the higher the high voltage is communicating with the pipeline, the more the AC density. The AC density is directly proportional to AC voltage, but it is inversely proportional to the resistivity of the soil and the size of the coating defect. So our task now is to look at this. If we are able to reduce the much communication between the transmission line and the pipeline by keeping them far away, meaning that the voltage in the pipeline will be reduced. That's the induced voltage will be reduced. If the induced voltage is reduced, then the density will be low. If the density is low, we are discontinuing the AC corrosion from happening. If the resistivity of the soil also is increased, or the coating defect is increased, we're also reducing the AC density tendency. So we're talking now about which is the main player in this AC corrosion, is the interaction of our high voltage transmission lines and the pipeline. So we have different forms of interaction. We have induced or electromagnetic, we have capacitive, and we have conductive. Capacitive is just like I'm laying a pipeline that is more than 30 meters close to a high voltage transmission line. So it's just like these artisans will do. They will just, anywhere they see, they start welding job. Anywhere they see, they just start doing some electrical job. But you may just get electrocuted. Just like I'm laying a long metallic section close to a high voltage transmission line, not knowing that this line is communicating with the pipeline. So what engineering advises is that if you are doing any work of this nature close to a high voltage transmission line, make sure you do the earthing properly. You ground the pipeline. You understand? If it's a short piece, no problem. But once it's more than 30 meters, according to standard, you try to introduce a grounding system. So that's for capacitive. Now, conductive is just like there's a thunder strike. We've seen cases where there's a thunder strike and people get killed because they're even far away from this high voltage transmission line. They get killed because probably they are close to one metallic object. You get? So the whole idea is these high voltage transmission lines may be due to faults. You know, they have like their foundation. There may be problems in their foundations, and you find that they are leaking current into the soil. It could happen. This also could happen due to maybe sudden strike, thunderstorm, lightning and thunder strike, and you have this high voltage transmission line introduce current suddenly into the ground. This could also go to the pipeline and could increase the voltage in it. But our concentration today, not on this capacitive and conductive. We're looking at AC interference due to inductive. Why we are talking about inductive is that this happens during steady state operation. It is there continuously. For capacitive to happen, that means I'm constructing like a pipeline close to a high voltage transmission line. I can prevent it easily. I'll be careful of myself. For conductive to happen, we can also guide against it, or this happens only when the lightning is massive or something. So, but inductive happen during normal transmission. You're just transmitting your power and you have your pipeline running. Okay, so during normal operation, this problem is there. So our own job is to make sure that we prevent this from happening and that our line is protected. We don't lose our content in the pipeline. So Faraday explains actually this whole concept of induction. When you have current moving on in your high voltage transmission line, it creates a magnetic field, and that magnetic field in its own also creates current and EMF on any pipeline, any metallic infrastructure close to it. So the rate of change of the magnetic field is equivalent to the much voltage that is that it's in the pipeline. So the whole thing is, the more the magnetic field created, and the magnetic field, the more the transmission voltage that you have on the high voltage transmission line, possibly the more the magnetic field, meaning that you have an equivalent of it introduced on the pipeline. So this is what Faraday explains, that the rate of change, it's equivalent to, directly proportional to the amount of EMF. E here is the electromotive force. Therefore, the negative sign you find there is just talking about Lenz's law. So, but basically, as
Hello,
I
Harry.
Yes.
Yeah. Okay. So you have 5 minutes more so that we can entertain questions
Okay,
from
fine.
channel box. Thank
Fine.
you. So
So
just try and round up 5 minutes. Thank you.
Okay. So the spread resistance, the more the more you have the coating defect, the less like we can see from the first part of the figure, the whole pipeline is kind of without coating. So meaning that when the alternating current goes into the pipeline, it kind of goes directly to the soil. The AC density becomes very less. So, but for cases where you have this spread lower, smaller coating defect, the AC density is concentrated. So the rate of AC corrosion, we kind of have when it's moderate, when it's high, when it's severe. So this is a formula, like you want to know the rate at which this AC corrosion is progressing. So we can also protect our pipeline from this form of corrosion. So if we are able to make sure that AC corrosion does not exceed 30, then our line is safe. If the DC is also less, does not exceed 1, our line is safe. So this just measures that guide us. So you understand. So to protect our pipelines from this form of corrosion, we can ground our pipelines. We can use DC decoupling equipment. DC decoupling means it will prevent DC from grounding and allow only AC to ground. So DC is like coming from the cathodic protection, because if we just ground the entire pipeline, both the cathodic protection and the AC will all ground, we all go to the ground. So, but we need our cathodic protection to protect the line. So this just, but to buttress, to see whether we have this case in our Niger Delta, a study was conducted. So 4 lines were chosen in the Niger Delta area. And these 4 lines, they were carefully chosen because they paralleled the high voltage transmission line at different sections. So one of the line was in Owaza, one in Aloji, one in, that's KCTL, one Oma gas pipeline. So the first one paralleled the 33 kV line. The Aloji line was a 132 kV. KCTA had 132 kV on mass. So this happened. 4 instruments were used for this study. The figure 22, which the ground resistance was used to check for soil resistivity. The CATEC was used for coating defects. The other one was used to monitor the coating corrosion, and the other one used to level of AC interference. So this just like schematics. Figure 26 was just used to how the pattern in which the AC voltage was measured, how much AC voltage introduced in these pipelines. Then the DCVG is to check if the pipeline itself has coating that will allow this corrosion to happen. So this is me just doing a soil resistivity test. The fence you see there is a Logi power plant. So just the schematics of figure 28 is just the soil, what happens for the soil resistivity test measuring. 29 is how the resistant probe works. So soil test for this location, soil samples were taken to University of Benin. This test was done in University of Benin Civil Engineering Soil Laboratory. And
hello, Doc.
I'm done. My time is
Doc,
up.
you have like just 1 minute. You can use 1 minute to round off.
So
let's have the conclusion of the research and possibly recommendations.
Okay, thank you. So the results, we had this resistivity. The resistivity was lower for wet season compared to dry seasons. Then the AC current was just move. Then also the coating defects. It was also realized that we had defects in this coating. Then the soil sample test results, the pH also measured. Different factors were considered: the cation exchange capacity, that the positive holding capacity of the soil and all that. So this is just the AC corrosion density and the AC corrosion rate measurement itself. So we can see that the AC corrosion was higher in the wet season due to lower soil resistivity than AC density was higher in the wet season due to lower soil resistivity. The amount of AC voltage for areas, because actually the test was done for areas close to the high voltage transmission line and another control section, because we want to check if the high voltage transmission line had any interaction. So it was like you do close to the high voltage transmission line, you go distance away also to do, so we can check if there is communication. So we saw that for areas that were close to the voltage transmission line, the high voltage transmission line had an effect on the pipeline, and there was like an effect. So this happened for the 4 pipelines this study was done. So, but summarily, the average rate of corrosion, we can see the average rate of corrosion for areas that were close to the high voltage transmission line and the areas that were far away. So these happened. So the pipelines laid parallel to high were higher for transmission. So, but basically, the main fact is that the Nigerian current maximum transmission, which we have at 330, does not pose major threat. Major threat means it does not pose major threat, like the AC density that we are accumulating from the 330. It's not as significant currently that we should be afraid of. But the fact is that the operators, the power line operators, should be mindful that as Nigeria progresses, as we increase our power rating, we should be careful in laying our pipelines close to them, because anything beyond what we have now, we're definitely going to begin to impact on our pipelines. I want to thank you for listening. Thank you so much.
Very much.
Thank you. Yeah,
Thank you very much. I would have interrupted, but I just didn't want to interrupt your flow of thought any longer, considering that I've already seen the last slide. Okay. So we'll go straight away to the Q&A section. We just have 5 minutes for that. So for now, I have about 2 questions on the chat box. Henry, I must say that you did a very great job there. Thank you very much for making out your time. And at the end of this section, I would also want you to kindly inform the participants where they can, get your papers if it is in a journal, so that they can be able to go through it, because we really didn't have much time for you to completely, finish your section. So the first question that we have in our chat box here is from one Cosmos Nnamdi. His question is, he said, kindly clarify the implications of using different schedules but same size of pipelines during sectional replacements of pipeline. That's the first question. I should take both questions, or you want to take them one after the other?
Okay, I can also see from here. So I think let me just say, kindly clarify the implication of using different schedules, but same size of pipeline during sectional replacement of pipeline. So schedule here, we mean thickness. Size, you mean diameter of pipeline. So these are choices that are made depending on what you need, the operating pressure and the parameters, the parameters in which going to, like, what type of fluid. If the fluid is very corrosive, you need probably higher schedules. So if the pressure is more, you also need maybe higher schedule. But basically, the choice of the thickness of pipe and the size depends on the size depends on the volume you are expecting. If the more quantity you require, I guess you need bigger size of the pipe. Then for the thickness, the higher the operating pressure, also you going to consider this. And if the element also, the fluid in which you're transporting is so corrosive, so you're going to look at the design life of the pipeline. So you're looking at, if this line is corroding at 1 millimeter per year, that okay, you have 25 years to use this pipeline before it will leak. But in all this, you must consider the grade of the pipeline, because the grade will tell you the corrosion resistance, the specified minimum yield strength, how much it can accommodate. I talked about it, like you have 35,000 PSI and all that, 60 up to about 80,000 PSI and all that. So that's it. I think, I don't know if I answered him correctly.
Yeah, kindly move on to the next question.
Okay, how can this AC corrosion be prevented if it has not yet occurred? And also how it can be corrected if it has occurred? So preventing it is to look at what are the contributing factors. You have AC interference from high voltage transmission lines, you have coating defect, and you have the soil resistivity. So the soil resistivity and the coating defect, both are basically not so much in your hands. You understand? So because you cannot, if the resistivity of the soil now in my village, it will be difficult for me now to just come and change it. It's what God has given to that area. Although there are some substances that can be introduced in the soil, it will increase or reduce soil resistivity, but majorly not in your hand. So the main thing you can control here is the voltage you are introducing in the pipeline. One, if I reduce the power rating of the high voltage transmission line, I will reduce the amount of voltage that is induced in the amount of current that is induced in the pipeline. If I keep the pipeline far away from the high voltage transmission line, I will also reduce the amount of induction. If I keep it also, like, if I want to cross, if I'm going close to a pipeline, I should try maximally to go at 90 degrees. Keeping the line to go parallel with the high voltage transmission line predisposes a larger section of the pipeline. this is about preventing it. So if it has occurred, there is something they call corrosion coupon. There's something called test post for every like 1 kilometer. Sometimes if you have road crossings or you have these high voltage line crossings during construction, we always put test posts. So test posts are like the point of communication with the underground pipeline. Because if I want to check the condition, or just like taking a BP, you need the BP device, you place it on the arm. So through there, you can communicate with the heart and know how the heart is beating. Same also, if you want to communicate with the pipeline, you will not excavate the pipeline and start checking the condition. You need a test post. So from the test post, I can check how much AC is induced on the pipeline. And if I want to go further, I can use a corrosion coupon of 1 centimeter square in size. I can monitor what happens to corrosion coupon. Is a coupon having the same properties with the pipeline. I can monitor what happens to it and try to know what to do. Know what to do means I can reduce the rating of the transmission line. Okay. Yeah. Hello, Kristen.
Thank you very much, Dr. Henry. Thank you very much. I think you really did justice to this paper. Like I said earlier on, I want to give you just a minute. You can just tell participants where they can get this paper so that they can also sit down and go through it properly before we hand over to Dr. Jude to continue with the rest of the section. Thank you.
Okay. I have this particular publication in World Pipeline magazine. I have it in, I think I'll check, I'll check with the link, and I'll send to Dr. Simobi. He will find a way to share with everyone. So I've published this work in a number of journals. You can just read up in any of them and just get. If you also need me to send to you, I don't mind. I know it's my hard work, but you can still get it, no problem, because it's already in the public, so there's nothing to keep away from everyone.
Okay.
Yeah,
okay, thank you, Dr. Henry. Okay, yeah, thank you, our participants. If you have any other questions as regards this paper presentations, you can drop it off. We can address later and send back the answers to those questions. So at this moment, we'll hand it over to Dr. Jude to continue with the section. Thank you.
Thank you. But perhaps if I could, take advantage, and I know Sir Pedro, you had your hand up. Would you like to get a voice in the room? If you still want to ask a question, sir. Hello.
Good evening, everyone. Thanks for observing that, but I actually raised my hand in error, so pass.
Okay, thank you. And once again, we're grateful for the presenter. I'm sure he could have gone on and on and on, but for want of time, and we lost quite some time at the beginning, we had to cut him short. We wouldn't mind to have you come again. Maybe if there are elements of the work you still want to present some level of granularity, we could find slots sometime to get you some airtime to talk a bit more in that, depending on how the appetite of the session goes. Thank you very much once again, and thank you also to our moderator for an excellent job well done. We'll continue with the rest of the SPA program, but to do justice to that, I have my section chair now.
Yes. Good evening.
Yes, please. Over to you, sir.
Yes, good evening, everyone. And Dr. Jude, thank you for holding forth. Let me first of all apologize to our speaker, Engineer Dr. Henry, and Engineer Calabo, Christian, and the moderator. So today we had a part of our end of year, as we end of board year. Today was a nomination of board members for 2023-2024 board year. So we spilled into the meeting time. So my sincere apologies. I actually joined and I've listened to the presentation, and I must really say that Engineer Dr. Henry, you are quite very vast and you've done justice to this topic. I see some requests that we would appreciate you to share this slide with us so that some of us that join late, we can take time to digest it. And by extension too, may I also appeal that you can share your email ID for some folks that may have some questions to ask. Thank you for taking our time. I know Dr. Jude has been chasing you and then keep shifting the date, but you've been patient on this. And then to our moderator, thank you also for keeping a date with Port Harcourt SP Section 103. We appreciate your time, we appreciate your knowledge sharing, and we appreciate that you are also supporting SP Vision and Mission. For our members, apologies to you also, and thank you for joining in this call. Dr. Jude, please keep in mind that we have to also send a certificate of appreciation to both the speaker and the moderator.
Yes, while you still have the mic, Simeon, can we go to the next slide now? Yes, SC, you can still carry on with this, please.
Okay, thank you, Dr. Jude. So to our distinguished speaker, this is just from SP Section 103, Certificate of Appreciation, and proudly presented to Engineer Dr. Henry Esabohen. Pardon me if I didn't get it correctly. For volunteering the speaker in a June monthly 2023 technical meeting on the topic AC corrosion of underground hydrocarbon pipelines. Thank you, and we will send it by email to you. Thank you very much. And to our moderator, again, on behalf of SP Port Harcourt Section 103, we proudly present this certificate of appreciation to you, Engineer Calabo Christian, for volunteering as a moderator in a 2023 June monthly technical meeting on alternating correct corrosion of underground hydrocarbon pipelines. Thank you, sir. And we would communicate via email your certificate of appreciation. Thank you, TIC. Over to you.
Thank you. Thank you very much, SC. Thank you. And thank you once again to our presenter. At this juncture, because we know that our presenters and moderator might get very busy with schedule, we'll kindly want to move again. I know the presenter is in an off-site location as he's presenting, so there might be reason to leave us. So please, Simeon and Essie, at your permission, let's move up the photograph section again so that we can all take a picture now and then continue with the rest of the SP activities. Thank you. Can we kindly turn on our videos now as many as can? Essie, you said you just deck, wear white. Why are you doing this to me now? All right, thank you. So please, Simeon, do your thing. Let's turn on the cameras, as many as can. I know the presenter might not be able to because of the same location issue. So let's just do this now. Simeon, over to you.
Okay. Yeah, in less than 1 minute will be done. Some video are still coming up. Okay. 10 seconds more. 5 seconds. And the last seconds. Thank you very much.
Thank you. So, I mean, that should gladden the heart of the presenter and the moderator this usually will be a face-to-face meeting, but because of logistics and other factors, and we really do encourage sponsorship from AGIP as our moderator or even our presenter. We really would appreciate some sponsorship so we can have more of these meetings face-to-face. But I'm sure seeing the video was helpful to know that you were speaking to humans and not machine. And thank you. We do encourage you to stay back and continue the rest of the program. We'll hope to round up shortly. And this is just for advert placement. Simeon, do we have someone from the comms to speak on this, on the call?
No.
Okay, I know it's been a very difficult period. So I'll speak on the monthly technical meeting again, as I was just saying last. Sponsorships are open for face-to-face. Technical papers are also open for acceptance, where we look through the abstract, scrutinize and select the best, depending on our focus at the point. Please do well to contact myself or any of the board members or the secretary directly, so we can have your papers and plan it and queue it for the rest. Thank you. I'll keep it short for time. I saw Dr. Kereke on the call. Doc, could you please come off the mute and speak to us on this line? Is this still around? Oh, no. Do we have someone from the communications committee that could speak, or membership rather? All right. So SP is an association, Society of Petroleum Engineers, but you can imagine with every engineering design and engineering practices, it cuts across several walks of life, from the subsurface to the surface. And we encourage members. We have students, we have research graduates, young professionals and senior professionals. And this is to encourage as many that are visiting in today, dial in today to listen to this presentation, to be a member. The main benefit for being a member is enormous. One of which is the technical meeting. And then you can imagine how many more you get to know. There's scholarship, there's sponsorship for activities, conferences where you see presentations like this in each tent or conference. So do well to contact any of us or through the secretariat, and you will be guided on how to become a member. Upcoming event announcement. The 2023 general meeting, it's coming up on the 21st of July. Members, please take note, 4 p.m. Events, red carpet opens and main event starts by 5. Dress code is your African attire and dress glamorous. Venue, Simeon, where is the venue, please? Sorry?
Venue is there is Kasoni.
Kasoni, okay. Please take note.
National Hotel at number 1 Presbyterian off Stadium Road.
Yes, off Stadium Road. Okay. What other announcement do we have?
That's all.
Okay. I think at this junction, I will still hand the mic back to the SC and PC for a vote of thanks. And then we'll wrap up this meeting today and go back to the rest of our activity. SC, DPC, over to you. Thank you.
Okay, maybe if DPC is here, he can just give a vote of thanks. That will be fine.
All right. Good evening, everyone. PC is here actually. I think I saw her. So if she's disposed, fine. But since SC have said I should do it, if she is not disposed, Dr. Osabo here, we want to say very big thanks to you. You're a Nigerian expert working in Abu Dhabi. Makes it special because you are coming with an experience from other parts of the world that we may not have really applied here. I heard you say something very unique, that what is in the soil also determines the corrosion strength. I'm putting it in my own way. So sometimes some people forget that while we walk on the earth, the mineral composition at different parts are different. So when we want to make such design, the soil characteristic matters. So thank you for making out time to make this presentation to us. If you are in country, maybe it's better for you, but if you're already operating from Abu Dhabi, that means at least plus 3 hours. So it means you're already staying late into the night to accommodate us. So we sincerely appreciate you. And then to my own dear colleague, Christine, I'm very happy that this mantle fell on you and you took it up. I want to be seeing a lot of my other colleagues come here. And thank you. I guess you are the first this year to be moderating. Thanks for making out time to be here. I can see Beatrice Calabo. I guess that's your wife. You've pulled someone along to be with us too. So you, in the true spirit of SP, you did not come alone. You came with another person. That's the SP slogan, come along with a friend. So on this note, I finally say SP is grateful, Section 103 is grateful to you for all your time, to both you, the speaker and the moderator, and we hope you will come again. Thank you.
Thank you very much, Sir Pedro. Ladies and gentlemen, thank you once again. And this is wishing you a good night's rest, a happy weekend, until we'll come your way again in the next monthly technical meeting. Nelson, is that very urgent? We're just wrapping up. But
someone needs to refer Nelson to the YP chair. He's just rejoining back into the family. Yes,
okay, so you are welcome. You are welcome in the name of the Lord. Welcome back. So, is that your hand raised up? Nwoye? Nelson, sorry, your hands are raised up, so I'm just trying to oblige. Is there something you really want to say to us? Okay.
So, okay, sorry, I was just trying to call your attention to as what I posted on the chat. Thank you, Mr. Chairman. I think we met the last time in Lagos, if you can remember. So sorry, I've not reached out to you. So I was quite busy with some engagement. So I just wanted to thank you for the monthly technical meeting. The presentation was nice. So I also joined the meeting, the YP meeting, I think 2 days back, but I wasn't able to connect with them to as in incorporate myself fully. So that's why I brought it here.
It's okay. I think it's been noted. So I'm believing that Simeon, all the YP members and YP chair and co-chairs should have picked it up quickly. Please, let's ensure that we pick this up. And thank you for speaking up, and also it's good to recognize your presence. All right, ladies and gentlemen, apologies, we kept you slightly later than we should, but it was worth it. I want to believe so. We've all enjoyed this technical diet for this evening. This is wishing you a good night's rest, a happy weekend until we'll come your way next month. Remain safe, remain blessed, and stay technically up and running. Good night.
Good night, everyone. Have a nice rest.
Bye.
Thank you.
Enjoy the rest of your weekend. Bye.
Bye-bye.
Good night, everyone. Happy weekend.
Good night, everyone. Happy weekend.
And good morning from my end, depending on where you are.
Good morning to you, Samuel.
Yeah, thank you. Okay, bye-bye.